everyone. Welcome to the HSPF training by DSI. This is course HSPF220. We are going to look at some hydraulic parameters of a free-flowing reach or mixed reservoir operation. It's also called RCHRES operation in an HSPF model, and we'll see how these operations connect with each other. So this is HSPF 220 UCI. In this one, in the operation sequence group, you will see that I added another operation called RCHRES1 right below the operation implant1. And this is the implant block that we looked at before. And I just go further down. And now there is a RCHRES block, a new block that I added. Activity, print info, binary info, general information is very similar to how it was for implant. The difference is in the parameter names. What modules are active and what are the names of different parameters that will be printed. General information has a couple of more information. One is n exits, number of exits. A reach can have more than one exit. Think of it as emergency spillways or a diversion to a separate part of the watershed. Depending upon the number of exits, for each reach, you have to change the n exits. Another difference you will notice is LKFG, lake flag. If a reach is a lake, then the bottom shear stress and dissolved oxygen are calculated a little differently. So in hydrology, it won't matter. So then we have hydro palm one. The palm one is always flagged, so these are different flags. In hydraulics, mostly it tells how the flow will be calculated. The flow in an HSPF model from a reach can be calculated based on the volume of water in a reach, or some time function, or some other time series conditional function that you can provide. We are going to look at very simple model here. So the point to note here is that this 4 says that fourth column tells us fourth column for the first exit, because our reach has only one exit. Fourth column will provide the value of outflow for the exit number 1. If we had 2 exits, then we'll say, okay, fifth column provides the value for the exit number 2. Sixth column provides the value for the exit number 3. That would be useful only if we had number of exits more. Other things, we can ignore that for now, but basically it tells that the flow from the reach is a function of the volume. Let's go to hydro palm 2. It's mostly GIS calculation, and length delta H. Stage correction is if you have datum value, and this has DB50 has to do with sediment process calculation, and we'll ignore it for now. Hydro init, what is the initial value of the water in the reach? This 20 acre feet, and that's what I have provided right now. And there, for more complicated models, the category, you can have the different category of waters, especially if you want to look at the age of water or the color of water. These are different column indicator when you have more complicated outflow from a reach. So we'll ignore that for now. For this model, 20 acre feet is the amount of water available in the reach. Then we come to F table. So F table can be very complicated, can be very simple. So what I decided was to make the simplest F table. In this F table, when the volume of water in the reach is 0, there is no outflow. When the volume of water in the reach is 20 acre feet, it's 1000 cubic feet per second outflow. It doesn't matter in this case. I just made it so that the water just empties out quickly, and it's simple to two row F table. What F table does is that it provides a relationship between depth, area, volume, and outflow. So outflow here is the fourth column, and if you remember from the Hyder Palm 1, the fourth column, for first exit, the fourth column is providing the uh, way to, is telling us how the water will flow out. Depth and area are calculated and they are used for different parts. Area helps to calculate how much precipitation will fall or on the reach, or how much water surface will be exposed to evapotranspiration. And that's it. This is the simplest F table. When you have more than one reach, one exit, you may add more column. And sometimes you can also provide the outflow through our time series from outside. So that is useful in dams. Then let's look at EXT sources, where we provide the precipitation and evapotranspiration to the reach operation, reach 1, using the same time series as before. In some cases, when the surface of the reach is not exposed to atmosphere, it's an underground reach, or it goes through a pipe, you may want to not include these. So these are not required time series. We have looked at this before. Then how does the water from implant that we looked at in HSPF 210 goes into a reach? That information is provided in two tables, schematic and mass link. So let's look at the schematic. What schematic says is that in RCHRES 1, get the output from implant 1 and multiplied by 10 using the rules provided in table mass link 1, ML1. Again, the inputs in this reach are coming from the output from the implant 1 multiplied by this factor according to the rules provided in mass link table 1. So let's look at mass link table 1 now. Mass link table 1 says that whatever surface runoff is calculated in the I water section multiplied by this factor, it's actually 1/12, and dump it into the inflow I vault, dump it into the water section of the RCHRES. Why 1/12? Because since it's English unit model, the volume of water is calculated on the surface as depth, that's in inches. The unit of water in the RCHRES is acre feet. So this converts that inches into feet, and this is where we can multiply the area. So that is where it becomes acre feet. So if you have more than one implant, if you had implant 2, and that also flowed into the same reach, and let's say it was 30 acres, and that is also going to the same reach or maybe different reach, but that will also follow the same mass link table. So the rule followed is same, the area multiplied is different. And if you had another reach, for example, and okay, so in this case you have another reach. So the water from this type of land is 10 acres is going to reach as 1, 5 acres is going to reach it as 2, and both are following the same mass link table. So in this case, this will, if I run this model, it won't run because it doesn't have these two operations, implement 2 and RCHRES 2, or it will just probably ignore these lines. But this tells you how different operations in an HSPF model are connected. In the next video, we'll look at the purlin operation and see how we'll add purlin into the same schematic block. Thank you.